Hello, everybody. Welcome to a very exciting talk on how you can harness the power of robotic process automation for rapid deployment of machine learning models. I'm Miriam, and I'm a data scientist at Rogers. I work with Shahid and Gonzalo, and I helped help them working on this model. Our two speakers are going to be Gonzalo and Shahid Amlani. Gonzalo Corrales is the Senior Director of Intelligent Automation at Rogers. His work focuses on identifying the business problems that can be solved through technologies like machine learning, intelligent automation, and others. As well, he understands the challenges in operationalizing those solutions, having deployed and implemented several of them in ways that deliver measurable financial results for organizations. Gonzalo holds a BSc in Electrical Engineering and an MBA from the Richard Ivey School of Business in Canada. Shahid is the Director of Machine Learning and Automation at Rogers. His work focuses on leveraging the power of machine learning to enhance the digital customer experience, solving problems for customers and deriving tangible results. Shahid has spent over a decade creating solutions that utilize the potential of technology and data to create real, measurable business outcomes. He holds a degree in computer science from the University of Toronto and an MBA from the Ivey School of Business. Gonzalo will be discussing the key elements of how we leverage robotic process automation, and Shahid will be walking us through the details of the model and some of the key considerations and challenges we face. I hope you all enjoy the talk. Gonzalo, over to you.
Thank you very much, Mariam. So before I start, let me take a few seconds to thank everybody who is attending this talk, and obviously to thank Dave Starbuck for having the kindness to invite us to deliver this presentation. Let me jump to the first page in the presentation. Give me 1 second. Okay, perfect. We thought we would start by setting up what is the problem that we're trying to solve. So the problem is as follows. For the last 20 years or so, every time our company or one of our customers would have an internet issue, an internet technical issue at home, the process would be as follows. Number one, the customer will feel the issue, and normally he would pick up the phone and call us. This customer will go through an IVR process and land with our technical specialists in technical support. At this point, the customer will have a troubleshooting discussion with our specialist, and this can have three potential outcomes. First outcome is the problem is solved. Right there in the phone, we are able to solve the problem the customer had. But pretty often, also, there are two different options. One, we need to send a track to the customer's home, because we have determined that there is an issue either with rewiring or the equipment in the customer's home. Another option is that when the customer was calling us the first time, we determined that this is not a one home problem. This is a neighborhood problem, or what we call an area issue. In that case, we need to send a maintenance crew, which is going to go to verify that the network laid out in the area is actually working fine. Over the years, though, we've also experienced a certain number of repeat, or what we call a repeat rate. For a number of challenges that we have in our operations, there is a number of customers that even though they have gone through this process, they still find the need to call us again. So that happens both after the customer thinks the issue has been resolved at the time of troubleshooting over the phone, or sometimes, regrettably, also after he has received a visit of a technician or a maintenance crew has been sent. The challenges with this model are obvious. At the highest level, number one, it's a very reactive model. We expect the customer to work for us and act as a detection system. The customer is the one that is going to tell us that a problem is happening or not. So a very reactive system. Number two, it's very high in operational costs. there is a very high component in maintaining a call center to handle all the hundreds of thousands of calls that we receive every year. And at the same time, there is a high cost in maintaining the field workforce of technicians that, in our case, runs in the thousands. With these come the regular operational challenges that we have managing such a large workforce. There is always attrition. There is always people leaving the company, new people coming into the company, the need for training for the new people coming into the company, and so on, which results, as I mentioned before, in a certain level of repeat rate that we can't avoid, and we have not been able to avoid in our operations for the last 20 years. So this is the problem that we're tackling with Shahid and I. And we said, okay, how can we make this better? How can we put this into the 21st century? So I'll move to the next page. Shahid?
Thanks, Gonzalo. Before we just continue, Gonzalo, is it possible to make it full screen? We're getting a lot of feedback in the comments that they can't see. If you can just go into slideshow, that'd be awesome.
Yep.
Thanks. There we go.
Perfect.
Perfect. Great. Thank you. Great. So when Gonzalo approached me with this problem, essentially what we were looking to do was try to prevent customers from entering that funnel or that painful process that Gonzalo just walked us through. So we really sat down and we decided to approach the problem in 3 simple steps. So since we're trying to prevent customers from entering that funnel, the first step was really, could we build a machine learning model that would predict which customers were about to enter that funnel? So essentially, could we predict who was going to have a technical issue? And if we were able to achieve that, if we were able to achieve number 1, then number 2 would be, okay, we now know who these customers are, but what are we going to do about it? What can we do in order to prevent them from entering this funnel? And that's where we think that RPA, or robotic process automation, is a key differentiator, because it allows us to really execute and handle these predictions very quickly. And Gonzalo will go through that in more detail as we deep dive number 2. And then the third step is really the outcome of this. So if we're successful at number 1 and we are successful at number 2, so we can determine the list and figure out what to do about it in a timely fashion, then the outcome will essentially be customers don't enter that funnel, or customers don't feel the pain of a service disruption, don't have to take time out of their days to call us, and don't have to have any negative customer experience. And then from a business side, of course, we don't have to bear the cost or the steps to actually fix those issues, because we've already handled them. So Gonzalo, if you want to go to the next slide. So if we deep dive number 1 a little bit, so basically, what are the steps, what are the challenges that we faced as we went through and started developing and deploying this machine learning model to basically predict those customers that were going to come into the funnel? So when we started on this journey, we looked across the many different data sets that we have at Rogers that were readily available to us for the most part. And this includes things like network telemetry data. So what kind of speeds are you getting? What's the quality of your signal? Equipment and usage data, what kind of modem do you have? Things like that. All the way to geographic data. So kind of where is our cable footprint? Where are our customers clustered? What kind of wiring is it? We took a wide lens to see what of this data do we actually think would be predictive. And over the course of the year, we had many iterations of the model, and they ranged from, depending where we were on the process, from considering 15 features to 50 features. And right now we've settled on a model that we're currently in POC with that considers approximately 40 different features. And these features range from looking at a customer's connection health today or yesterday to considering kind of the patterns and the different metrics over a period of time, anywhere from 15 to 30 to 45 days. Now, from a training perspective, we're currently looking at using about 15 million records. We're still working on optimizing this for both performance, runtime, and cost, but it seems to be working relatively well right now, and we'll continue to iterate on this to try to make it better. Now, when it comes into the actual modeling, this is a binary classification model. So we're basically taking our entire base and segmenting them into who we predict is going to call and who we predict is not going to call. We did start with a random forest model, but as you can see, we quickly moved to an XGBoost model to And that was primarily to handle our imbalanced data. And I'll get into that a little bit later on. Now, currently we're running this model daily. So we're producing a list that contains a list of who we think is going to have a technical issue tomorrow. And we're passing that list over to RPA for actioning. Now, overall, the modeling, it's not super complicated, right? But over the past year, there's been a number of key considerations and decisions that we've had to make, both from a machine learning perspective as well as a business perspective. The first one that I'll kind of go through, that's probably one of the more impactful ones from a benefit realization perspective, is the recall versus precision trade-off that we needed to make. So we could either be really precise in our prediction of callers, but not capture a lot of them, or we could be wrong, like sacrifice some of this precision, but capture more of these callers. So in order to weight these things from a business perspective, we really needed to look at and determine internally kind of what was the cost of being wrong. So if we think about it, what was it, right? If we had a wrong prediction and we included that prediction on the list, we would send that prediction to RPA. RPA would then determine why that customer is on the list and why we think they're going to call us with an issue tomorrow. And they would take the necessary action that they thought was required to prevent that customer from entering that funnel or from actually calling us. Now, these actions, they can range from contacting the customer, booking a truck roll, rebooting their device, a whole host of things. And Gonzalo will get into more of the specifics. But the point being here is that that customer would be impacted. Like we may impact that customer with the action that we're taking in order to fix that problem. And in this case that we're talking about, because the prediction is an incorrect prediction, we'd be impacting that customer unnecessarily. So due to this, there's some risk there, right? There's a brand risk for Rogers. There's a cost impact of unnecessarily taking actions that we don't need to take. And there's also a customer experience risk. As we may interrupt a customer, we may contact a customer when we don't need to. So the approach we've decided to take is really to, in the early stages at least, weight precision significantly more heavily. And as we start to see success as part of the action layer, we'll slowly start to loosen the constraints and see how the model performs. Now, the second key item that we faced is really focused around our entire data. Now, I won't go too much into data cleaning, just to say that it was probably one of the more time-consuming and difficult parts due to the very nature of the data and the various systems it's coming from. If you have questions or want more detail on that, feel free to ask in the comments, and I'll go deeper into it. But the more challenging item that we had, however, was really the handling of our vastly imbalanced data. Originally, we were testing on a balanced data set, and of course, we were seeing wonderful results. But that's not even close to what reality is like. If you think about any big company, like a telco or insurance company or a bank, anybody with several million customers, of that base of customers, only a small single-digit percentage is really going to call you on a given day. So what that does is it results in a very large class imbalance between your callers and your non-callers. To handle this, we eventually migrated our model to an XGBoost model, and through painstaking hyperparameter tuning, and specifically leveraging some of the parameters with XGBoost, like the scale POS weight parameter, we're starting to see acceptable results for the call class. And they were acceptable enough for us to start the POC with Gonzalo, and we've got a use case out there that we're starting to see some promising results on. Now, this continues to be a challenge for us, and we're continuing to optimize, but right now we're pretty happy with where it's at. And the last piece that I'll just go through is one of the more interesting learnings that came out for us through our feature engineering steps. So when we originally started, we expected certain data points to be predictive that actually ended up not being so predictive in the first couple of rounds. So as an example, we expected intuitively that the health of a customer's connection today would be predictive. So if you had a poor connection today, we would expect that you're going to call us, but it wasn't. And over some time, what we came to learn was it wasn't necessarily the raw score of the customer's health or the health of the connection in that moment, but really how that connection health compared to what the customer was used to. So we as a company have business metrics and thresholds to determine whether a connection is good or bad. But in reality, What's going to cause a customer to call us or cause a customer to have an issue isn't necessarily what we define as the threshold, but more what the customer is experiencing today versus what they're used to experiencing. So as we started to update these features and think about it in this way, they've become significantly more important, and we're starting to apply that line of thinking to various business problems across the company now that we're trying to solve. So overall, we're going to continue iterating on this model. We have aims to make it better, but we're very proud of where it is currently. And as we produce those lists, we pass them on to RPA, and there's a whole action layer that Gonzalo will take us through now.
Okay, thank you, Shahid. So yes, once Shahid had a model to a level where we both sat in a room and discussed whether there was a business case here, when precision and recall were at the levels that we said, okay, yes, even considering the cost of being wrong on a certain percentage, we could still make this work from a business perspective. Then is when we actually got into action on the RPA side. So our aim on the RPA side was to build some modules that were going to take the output of the machine learning model and actually do something with it, put it in operations. So we get now an output of the model on a daily basis. We get a prediction of which customers are going to be calling tomorrow with a technical issue. And when I say tomorrow, it's literally tomorrow. Right? So that is then fed into a number of RPA modules that we have built with our subject matter experts at Reuters. And those modules will run diagnostics on these customers that are in the list. These different modules will zero in into a root cause, or the most probable root cause. Once we get to an acceptable level of confidence that we have identified what the root cause is for this customer to be experiencing a technical issue, we jump into action. That is then the action layer. And the action layer, we use robotics because it's a very flexible technology, but at the same robust enough that we can handle thousands of customers in this way. The robotics automations jump into action and trigger what the corrective action for such a problem would be. For example, if the problem results to be an area issue, if we run the diagnostic tools and we figured out that this customer is experiencing an area issue, he is going to call, but the problem is actually being experienced by all his neighbors around. If there is a group of 20 or 40 homes that are experiencing the same issue. So what we will do is we will definitely book a maintenance crew to go there in day so that we solve the issue before the customer calls us. But at the same time, we're going to use communication platforms like SMS, emails, or even auto dialers to connect with the customer and let him know that, Mr. Customer, we have identified you're experiencing an issue, a technical issue. Give us the opportunity to fix it. We'll keep you informed through the process until the issue is fixed. Finally, the RPA will also log these actions in a database that we have built, especially for this purpose, to make sure that the actions are logged. We track the resolution. We track the metrics and diagnostics and health signal health levels of our customers so that we verify and validate that the action that we took actually solved the problem. Of course, one of the key metrics that we track over here is how many of those customers that were on the list actually ended up calling, and we compare that with our baseline before. We are going to use this database that we built specifically for this purpose in a way that we are going to feed that back into the model and make the model better and more accurate. One of the biggest challenges that we have over here, of course, is that the model tells us who is going to call, but it doesn't tell us why, for a number of limitations that Shahid will probably comment somewhat in a second. What we want to use this data that we are collecting through this action layer, we want to feed it back into the model so that the model doesn't need the RPA to determine what the root cause is, but actually the model will tell me right away what the root cause is likely to be, and therefore I can jump even faster into action. Shahid, you want to take the last one?
Yeah, sure, no problem. So as we've gone through this, we've we've learned quite a bit. So our next steps, and I see some of the questions kind of flooding into the chat a little bit around kind of root cause and things like that. So absolutely, to a lot of the feedback that's in the chat, our next step is we really want to continue developing the root cause analysis for predicted callers. So as some of you have noted, right now we are really just predicting whether a customer is going to call or not call. We do have the aspirations to get to a point where we can predict the reason for that call, or basically why they're unhappy, so that we can short circuit some of this process so that we can action them faster and potentially actually fix the issue further upstream. The reason for kind of doing it the way we are today is more focused around speed execution. So this was the kind of the fastest way we could do a POC, but we do have aspirations to get there. So number one, we're absolutely going to continue developing the root cause analysis, both from an RPA perspective in the current function, but also from an ML perspective, and that's number two, right? So we want to continue to evolve the model. So one, we want to leverage the results from RPA. So RPA is determining, why customers are calling, and that's valuable information for us as we can use it to benefit the model over time. And then there's other data sets within the company that we have and that we have access to that we just haven't been able to incorporate for a variety of reasons. But there are some promising items there that we are looking to incorporate over the next few quarters, and we're hoping to continue evolving this and expand this POC, quite frankly, from where it is today to more broadly across the business. Anything else to add, Gonzalo?
I think you covered it all. If there is any questions from the audience.
Great, I think we have a couple of minutes, yeah. Miriam, any questions that resonate? Miriam, you there? There we go.
I came back. Yeah, there are a bunch of questions from the audience. One question for Shahid. One question that I see that a lot of people are asking is about the environment, and like what environment is Rogers basically building this model on? Is it on-prem or is it cloud? That would be good to answer.
Yeah, absolutely. So this specific model, so okay, let's go backwards a little bit. So Rogers does have an on-prem environment, of course, and we use a cloud environment for this machine learning. So we are doing this in AWS. As a company, Rogers utilizes both the major cloud providers. But this specific model is built and deployed on AWS, and we pass it back on-prem for Gonzalo to be able to actually action the predictions. We do have aspirations to change that in the coming quarters, but that's the current setup right now. And again, it's balancing off kind of technology trade-offs and speed execution.
Thank you. Gonzalo, there's a question for you about which RPA tools were actually leveraged, and then how widely was this model deployed in terms of Rogers customer areas?
Yeah. Okay. Thank you for the question. Yes. So Rogers uses a number of RPA technologies, but the main ones are UiPath and Blue Prism. So both technologies were leveraged to build this action layer. Today, this model is working across all Ontario, which represents pretty much close to 90% of the Rogers customers. We expect to include the additional 10%, which falls outside Ontario in the Atlantic provinces, probably in the next 6 months.
Thank you so much. Shahid, another question for you around the model. Basically, some of the audience, they want to know like an example of the most predictive features that you have in the model, and then the current precision recall of the model.
Yeah, sure, absolutely. So from a feature perspective, what we're doing is we're really, so the most predictive features of the model are essentially most of the network health features. So it's not super surprising. And when I say network health, I mean, like what is a customer experiencing with their connection? So how fast is it? What's the quality of it? So things like packet loss and things of that nature. The other piece that's quite, I guess, intuitively predictive and shows up quite a bit has to do with Wi-Fi. So like we all use Wi-Fi significantly a lot, and the signal strength coming into your home, as well as the signal strength to your end user devices, is definitely showing up very prevalent in the model. And something interesting is just, we started this model kind of pre-COVID, and what we've seen is that the features that were important before COVID continue to be important after COVID. So it's still related to the quality of the connection, the quality of the Wi-Fi, how many devices are actually connected to the service, what kind of usage the customer actually has. These are really bubbling up to the top. And like I was saying, we do have aspirations to include additional data into that model. So we have some better metrics that we can build in around the quality of the area. So not just the connection to the customer's house, but also the connection to the area and what kind of the neighbors are feeling and things like that. And we think that'll help to better inform the model based on what we've seen so far. So pretty excited about that, and hopefully that improves the model over the next few quarters.
Thank you so much. I think we're running out of time, but I'll ask just one more question from both of you, actually. What was the most difficult roadblock that you had to overcome in order to actually deploy this model at Badgers?
You want to go first, Gonzalo?
From the RPA perspective.
Well, from the RPA perspective, I'd say that building the RPA modules was not definitely the challenge. At Rogers, I think we have developed quite an expertise on developing these kind of automations. We have around 600 digital workers or virtual workers at this point in time. The biggest challenge was, and Shahid kind of alluded to that at a certain point, which was the cybersecurity implications of transferring the data from where the ML model resides and runs every day to the environment where the RPA virtual machines are. So the cybersecurity implications of transferring personal information, because we have identifiers of customer numbers and so on, I would say that was the main challenge on my side, which is not unusual for the applications of RPA that we are building these days. But I would say that was the one that took the longest time. Shahid, on your side?
Yeah, absolutely. So from a time perspective, like making sure data security, anonymizing data, all that kind of stuff is probably the longest pull from a time perspective. While it may not have taken the longest amount of time, from my perspective, the biggest challenge we probably had was sourcing data, to be frank. And it doesn't sound like it's a difficult thing, but Rogers, along with a lot of big legacy companies, has a lot of data that is fragmented across the company. So it's not stored in a central place. And identifying the data we needed wasn't super difficult, but actually going across into the different areas where it's stored, identifying where it lived, and pulling that data into the environment in the way that we needed to was probably the most difficult. There's a lot of different things to consider from a cybersecurity perspective, from a data aggregation perspective, and that took a while, and it really took a lot of thought across the company to figure out how we were going to aggregate this data in an intelligent way so that it wouldn't just be kind of one and done, that we would be able to use this long term. So it's a work in progress, but that's probably the biggest roadblock that we found, and probably one of the biggest benefits that we'll have coming out of this, because it'll make it easier for us to continue to build models like this and keep deploying.
Much. There are some other questions on the chat, but unfortunately we're out of time. I'm probably I'm sure that you can reach out and then ask questions if you would like after the session. Thank you so much. I hope you all enjoyed the talk. It was really good, and I enjoyed it. Thank you so much.
Thanks, everyone.
Thank you, everyone.